All right, so now we're going to talk about different types of data. And this is a little bit different than the taxonomy of data that we spoke about before. So the first thing to talk about is the differences between a population and a sample, and then what a random sampling is. And in reality, what we look at here is that, let's say we have area of interest, let's say geographically, and this inside the circle is 100% of the people that we're interested in. This could be like all of the students at Appalachian State. Um, and then we don't have that ability to be able to survey all the students. So what we decide to do is cut out a small amount of the campus student body and say, all right, well, we're going to take samples of these people right here. And this might be like 2,000 students. And the idea is that these 2,000 students represent or are representative of the entire population of students. So the small circle is a sample, the large circle is that entire population. And what you might do is take 2 or 3, maybe 4 different samples, and this becomes random sampling, and you just randomly pick your samples. You don't plan anything from it. You just take them completely as they arrive at your location, and that would be considered random sampling. Now, now we're going to take a look at the difference between categorical and quantitative data. Now, earlier we had our taxonomy of data. That quantitative data is also could be called numerical data. And basically, this is something that we can apply arithmetic operations, such as add, addition, subtraction, multiplication, etc. Categorical data, you can't do that. You can't subtract Wednesday from Monday, or Monday from Wednesday, or however you want to look at it, or November from January. Or you can't necessarily subtract male from female. So these are categories, right? You can assign them values in order to make them numerical, in order to perform mathematics on it, but by nature they are different categories. And the last is cross-sectional data versus time series data. And the idea about cross-sectional data is that if I had, let's say this vector here represented time, and at this end is today, and then over here at this end where I have a t, that is the future. And let's say in 2 days from now I take a sampling of surveys from students here on campus, and that's all I'm going to measure. So that would be several entities at an approximate same point in time. But however, I might change my mind and then continue to take samples once a week, right? And this may be of the same people or different people depending on the boundaries of your study. And then you're going to then evaluate people's like ideas over these periods of time. And this represents time series data where basically data is collected over time. So this, very much applies to like temperature, for the climate and whatnot. We're looking at changes between those different points in time. Now, in descriptive statistics, we look a lot at the frequency distribution as a distribution from data. We'll be doing some creating some histograms in our class. But one of the things to know is that on the x-axis here, typically what happens is we'll create a bin for a continuous variable, like we might say that between 5 and 15. And then we say that we have observed a certain number of observations in that certain bin, and that's what allows us to create, get a count of items or observations that exist in that particular bin. And so that count is actually our frequency. And we have different bins across a spectrum from one end to the other. And typically what happens is this normal distribution curve gets created, and this becomes the basis for a lot of statistics when we evaluate the normal distribution. And one example of that is we start to take a look at measures of centrality such as the mean, median, and mode. And the mean is simply going to be the average of all the values, and for a normal distribution that's in the center. Now the median is where, if the data is arranged in ascending order, right? And if that's an odd number of observations, it's the middle value is the median. If it's an even number of observations, it's going to be the average of the two middle values. So that's how we determine the median. And typically in a normal distribution, the mean and median are exactly the same. Another value is the mode, and the mode is usually the most frequently occurring data in the set, or the most frequently occurring observations in a data set, and for a normal distribution, that usually is the center. However, if you have a skewed distribution, which might look something more like this, the most frequently occurring observation is off here in this sense, and that would be the mode for that particular data. We'll talk about that more as we get through this chapter. So here are the mathematical definitions for the mean, and then the median and the mode, and we've talked about those on the previous slides. Now we're going to look at measures of dispersion. So range is simple. It's simply the maximum value minus the minimum value, and that distance between those two is the range. Now the variance is that every time you take a sample or a measurement of something, points are not always perfect. They have some kind of spread. So variance is simply the deviation of all the points in that data set. So what is that separation that is occurring between all those points in the data set? And the standard deviation is a positive square root of that variance. Right? And so mathematically, dispersion is defined as the degree of variation in a given variable. The range is the max minus the min. So that variance is the sum of all of the values inside that particular data set. So it's basically that value minus the average of that data set squared divided by n minus 1, and that's the sum value of all that. And the square root of that ends up becoming the standard deviation. So you kind of see how these values are exactly the same. So these are measures of dispersion. So a lot of times when we deal with data, if we're not looking at a histogram or a normal distribution, we also can look at a box and whisker plot. And a box and whisker plot shows us where certain quartiles are. Now, and quartiles actually represent, in a box and whisker plot, the data set as if it was split in distribution, so that way that there is equal numbers of observation in each range. So for example, 25% of the observation will be in this quartile, 25% in this quartile, and so on and so forth. So that's quartile 1, that's quartile 2, that's quartile 3, that's quartile 4. And a lot of times a box and whisker plot will basically provide us where the minimum value is and the maximum value is. Now, if a value is smaller than 1.5 times the lower quartile, that's going to start to evaluate outliers. And this also applies to the upper value. And if a value is 1.5 times the upper quartile, we also get some outliers. So this in many ways becomes very similar to a distribution, but kind of put on its side like that. And what this shows us is that these values here sometimes are going to be outside the mean plus or minus 3 standard deviations. So these would be those outliers.